All right, welcome back to another video. In this episode, we are going to talk about the revolution or the surface area. Okay, so when we talk about the surface area in integration, that is basically one of the applications of integration. Okay, so with that, what you do is that you just multiply 2 pi. Okay, it's all about formulas. Okay, so multiply 2 pi by the integral of a particular function over a limit. So from a lower limit of a to b, right? So with that times the function. Okay, so basically that is what we have here. That is the formula for the surface area. Okay, so let's take a problem. So basically with the revolution or the surface area, we have where we can rotate about the x-axis and where we can rotate about the y-axis. But here, basically, right now we are talking about the rotation about the x-axis. So let's look at this particular problem and look at how we can deal with um, revolutions or surface area problems. Let's dive into it. So with this problem we have here, we have y equals root of x. That has been rotated over this interval x less than 4 less than or equal to x less than or equal to 9 about the x-axis. Okay, so y equals root of x is basically f of x. All right, so f of x is basically equal to the y. Okay, and that is equal to the root of x, and that is equal to x or half. All right, and it has been rotated over this interval 4 and 9 inclusive. So we have the interval to be 4 and 9. Basically, that is the a equals 4 and b equals 9. Right, so we have this interval, we have the function, we want to find the, how do you call it, the revolution or the surface area. So what we do is that we find the first derivative to the function, square it. We have the formula right here. So let's dive into it. So our first derivative to the function, which is x power half, is going to be half x power negative half. Okay, so once we have the first derivative, then the square of the first derivative is going to be half x power negative half all squared. So that is going to be 1 on 4 x power negative 1, x power negative 1. Okay, so once we have this information, the rest is substitution, um, computations, and the rest. Okay, so we're going to have our surface area, which is denoted as SA, is equal to 2 pi, all right, 2 pi. Then we integrate over the interval, which is the lower limit is 4 and our upper limit is 9. Then we take the function, which is x power half, okay, x power half, multiplied by the square root of 1 plus this we have right here, the first derivative all squared, and that is 1 on 4 x power negative 1. Okay, so once we have these informations, the rest is differentiation and integration. Okay, so let's consider this function. So we're going to have xa, which is going to be equal to 2 pi integral from 4 to 9 x power half, right? Then square root of 1 plus 1 on 4 x power half is basically um is basically 1 plus 1 on 4 x. Okay, so that is basically okay, let's bring our dx first. Okay, so we're going to have our surface area equals 2 pi integral from 4 to 9 x power half. Okay, Then let's try to represent, or let's try to find the LCM for the function under the root sign. Okay, so when we do that, we're going to have square root of 1 plus 4x all over 4x, right? Then we have the x here. Okay, so once we have this information, we can say that this can be represented as, or this can be expressed as, from this to this limit, x power half. Then we know that this function under the root sign can be expressed as root of 1 plus 4x all over root of 4x times the x, right? And we know that this can further be expressed as, x power half root of 1 plus 4x all over root of 4x is basically 2 root of x, right? And root of x is basically x power half, right? So we can see that x power half is here, x power half is also here. So that can go off, and we have 2 here, we have 2 here. So we are 1 on 2 and times 2 is basically going to be 1. So this also takes off this. So you're going to have our surface area. Our surface area is going to be pi from integral from 4 to 9, then root of 1 plus 4x dx. Okay, so once we have this information, we can go ahead and do u sub. Okay, so applying the u substitution, we can say that let u equals 1 plus 4x right here. So differentiate both sides, we have 4 dx. Okay, so we're going to have our dx to be equal to du on 4, right? So we do substitution, and we're going to have we're going to have our surface area is going to be equal to pi, the integral from 4 to 9, then root of u times du on 4, right? So let's try to bring 1 on 4 out. So we're going to have our surface area to be pi on 4, right? The integral from 4 to 9, root of u, and root of u is basically u power half du. Okay, so once we have this information, we can integrate now. So when we integrate u power half, it's basically going to be u power 3 on 2 all over 3 on 2, right? Um, over the limit 4 to 9. Okay, so let's move here and continue our right. So we're going to have our surface area to be equal to pi on 4, then integrate from um, u, which is 2 on 3, u power 3 on 2 from 4 to 9. But we said that u should be 1 plus 4x. Okay, so we're going to have u equals 1 plus 4x. So we have our surface area to be equal to pi on 4 into 2 on 3, 1 plus 4x power 3 on 2 from 4 to 9, right? We can factor this out, and we have our surface area to be equal to 2 on 3 times 1 on 4, and that's basically 2 on 12, right? 2 on 12 pi. Then we integrate 1 plus 4x power 3 on 2 from 4 to 9. So when we do this integration, let's substitute the limit. Okay, so when you do the necessary substitution, this is basically 1 on 6 pi into, when you put 9 here, we're going to have 1 plus 4 into 9, all power 3 on 2 minus 1 plus 4 into 4, all power 3 on 2, right? So this is basically 1 pi on 6 into 1 plus 4 times 9. 4 times 9 is basically 45, right? So we're going to have 45 plus 1, that is 46 power 3 on 2 minus 4 for 16 plus 1, it is 17 power 3 on 2, right? So basically, when you simplify this, then you're roughly going to have 46 power 3 on 2 minus 17 power 3 on 2. That is basically 154 pi on 6 into 154.9694, right? Now let's combine the results. Okay, so when we combine the results, then we are going to have surface area to be equal to 81.1418. This is surface area, so we can we don't know the exact area that we are talking about, whether it's a rectangle or whatever. So the best unit we can add to this is unit squared, right? So we're going to have 81.1418 unit squared, right? So this is the surface area to this particular problem. Or this can be expressed as surface area equals pi on 6 times 25.82823 unit squared. It's either you leave it in the pi form or you leave it in decimal form. So basically, that is the end of this particular problem. Ladies and gentlemen, thank you very much for watching. I really appreciate your time. Don't forget to subscribe, share with your mate, and I'll give you more updates. Bye bye.